students, welcome to the next video of derivative. In today's video we are going to see the derivative of inverse trigonometric function by substitution method. In previous video we had seen the derivative of inverse trigonometric function by using the simple trigonometric formula. Now in today's video we can find the derivative of inverse trigonometric function by substituting terms. Okay, now for substitution method, first you have to recollect some trigonometric formula. So let's start with revision of trigonometric formula. So first formula is sin 2 theta is equal to 2 sin theta into cos theta. Okay, this can be also written as 2x into root of 1 minus x square, and we can put x equal to sin theta or cos theta. Then this sin 2 theta, there is a one more formula for sin 2 theta, and that formula is sin 2 theta is equal to 2 tan theta upon 1 plus tan square theta. Now when we put x as tan theta, then we get 2x upon 1 plus x square. Then cos 2 theta formula, there are three formula for cos 2 theta. First is cos 2 theta is 1 minus 2 sin square theta, and when we put x as sin theta, then we get 1 minus 2 x square. Then second formula is 2 cos square theta minus 1, and when we put x as cos theta, then we get 2x square minus 1. Okay, then third formula is 1 minus tan square x upon 1 plus tan square x, and when we put x as tan theta, then we get 1 minus x square upon 1 plus x square. Okay, now tan 2 theta formula. So tan 2 theta is 2 tan theta upon 1 minus tan square theta, and when we put x as tan theta, then we get 2x upon 1 minus x square. Then sin 3 theta is 3 sin theta minus 4 sin cube theta, and by substituting x as sin theta, we get 3x minus 4x cube. Now cos 3 theta formula. So cos 3 theta is 4 cos cube theta minus 3 cos theta. Now when we substitute x as cos theta, we get 4 cos cube theta minus 3x. Tan 3 theta formula is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, and when we substitute x as tan theta, then we get 3x minus x square upon 1 minus 3x square. Now for the expression of the form, suppose expression is given as under root of 1 plus x square plus x, then we have to put x as tan theta. Okay, when expression is given in the form of 1 upon under root of 1 plus x square, then also we have to put x as tan theta. Okay, remember this part. If root of 1 plus x square is given either in numerator or denominator, then we have to put x as tan theta. Okay, then if x upon root of 1 minus x square is given, or root of 1 plus x upon 2 is given, in both the cases you can put x as cos theta. Okay, if this is the form, then you can also put as x as sin theta, either sin theta or cos theta. Okay, so these are the some formula which we are going to use to solve the sum. So let's start. Let's see some example. So first example, as you can see, question is if y is equal to sin inverse root of 1 minus x square, then find dy upon dx. Okay, here y is given as sin inverse root of 1 minus x square. Now root of 1 minus x square is given, so either you can substitute sin x or cos x, but here outside this sin inverse is given, and that's why we are going to substitute x as cos theta. So when x is equal to cos theta, that means theta is equal to cos inverse x. Okay, so sin inverse root of 1 minus cos square theta. Now 1 minus cos square theta is sin theta. So sin inverse sin theta. So sin inverse sin cancels, so that is equal to theta. So theta means cos inverse x. Okay. Now y is equal to cos inverse x. Now we are going to differentiate y with respect to x. So derivative of y is dy upon dx, that is equal to minus 1 upon under root of 1 minus x square. Okay. Then see the second sum. Second sum is, if y is equal to sin inverse 2x into under root of 1 minus x square, then find dy upon dx. Here we have to substitute x as sin theta, and so we get theta as sin inverse x. Okay. Now let us substitute. So what we get? We get sin inverse 2 sin theta into root of 1 minus sin square theta. But root of under root of 1 minus sin square theta is cos square theta, and root of cos square theta is cos theta. So finally what I am getting? I am getting sin inverse 2 sin theta into cos theta, and 2 sin theta into cos theta is a formula of sin 2 theta. So I am getting sin inverse sin 2 theta. Okay, and that is equal to simply 2 theta. But theta is what? Theta is sin inverse x. So that is equal to 2 sin inverse x. Now differentiate y with respect to x. So dy upon dx will be 2 into derivative of sin inverse x is 1 upon under root of 1 minus x square. So final answer is 2 upon under root of 1 minus x square. Okay. Let's see one more example. Third example, differentiate sin inverse 2x upon 1 plus x square. Here we have to substitute x as tan theta. So theta will be tan inverse x. So what we will get? We will get sin inverse 2 tan theta upon 1 plus tan square theta. And this is nothing but the formula of sin 2 theta. So finally we will get sin inverse sin 2 theta, and that is equal to simply 2 theta. But theta is what? Theta is tan inverse x. So 2 into tan inverse x. Okay. Now differentiating y with respect to x. So we will get dy upon dx as 2 into 1 upon 1 plus x square. So 2 upon 1 plus x square is the derivative. Okay. See some more example. If y is equal to tan inverse root of 1 plus cos x upon 1 minus cos x, then find dy upon dx. Now 1 plus cos x is a formula of 2 cos square x upon 2. Okay. And 1 minus cos x is equal to 2 sin square x upon 2. Okay, we are directly using the formula of 1 plus cos x and 1 minus cos x. Then 2 cancel, right? Cos square x upon 2 upon sin square x upon 2, that is equal to cot square x upon 2. Okay. Then root of cot square x upon 2, so root and square cancel, so that is equal to simply cot x upon 2. Now this cot x upon 2 can be written as 10 pi upon 2 minus x upon 2. This is what? This is allied angle formula. Okay, by using allied angle we get cot x upon 2 as 10 pi upon 2 minus x upon 2. Now tan inverse 10 cancel, so that is simply equal to pi upon 2 minus x upon 2. So finally what I am getting? I am getting y as pi upon 2 minus x upon 2. Now differentiating with respect to x. So derivative of pi upon 2 is 0. Derivative of x upon 2 is minus 1 upon 2. Okay, it is in the form of kx. Derivative of kx is k. So derivative of x upon 2, that means 1 upon 2 into x is given, right? So that will be 1 upon 2. Okay, so derivative is minus 1 upon 2. See one more example. Fifth example is, if y is equal to tan inverse x upon root of 1 minus x square, then find dy upon dx. Okay. Now here y is equal to tan inverse x upon under root of 1 minus x square. Now we can substitute x as sin theta. So theta will be sin inverse x. Okay. So what we will get? We will get sin theta upon under root of 1 minus sin square theta. Now 1 minus sin square theta is cos square theta and root of cos square theta is cos theta. So finally under bracket what I will get? I will get sin theta upon cos theta, and that is equal to tan theta. So tan inverse and tan cancel, so finally that is equal to theta. Okay, so finally what I am getting? I am getting y as sin inverse x. Okay, by substituting theta value. So theta is sin inverse x, so y is equal to sin inverse x. Now differentiating y with respect to x, so dy upon dx will be 1 upon under root of 1 minus x square. Okay, so this is the derivative of given question. Okay, see some more example here. Okay, I think both are same, right? So with this I am concluding this video. In next video we can see the more examples of derivative. So thank you students. Good day.